Hey class, today we're going to continue on with chapter 2 and we're going to move on to section 3. Section 3 is about chemical properties. We've heard this word properties before, but instead of chemical, we learned about physical properties. These were discussed in the last section. And what we're going to do is we're going to take those physical properties that we learned into the last section and we're going to relate them and see how they compare to chemical properties that we're going to learn in this section. So let's go ahead and get started. It starts off by giving us a picture of these candles and it asks, how would you describe these candles? You could describe them by giving their color, hardness, or their density. All of these things are physical properties that we learned about in section 2. So remember, physical properties are anything that can be observed or measured, and the substance's composition or chemical makeup does not change. For example, I can say that these candles are pink. They're not very hard because you're able to scratch them, and they are less dense than water since they're floating on water. All three of these properties I was able to observe, and they didn't change into something new. They stayed candles. However, you can also say that these candles are able to burn. You can see the flame in the middle of them. Burning, however, is not a physical property. Whenever you burn something, it doesn't stay a candle. In fact, it creates new substances, which is going to be one of the main key things to take away from this section. So, our key question that we're going to answer is, when can chemical properties be observed? Let's look back at that candle example that we've been working on. As a candle burns, I said that it created new substances. Well, the two new things it makes are two gases. The way it does this is that the candle combines with oxygen in the air, and one of the gases that it forms is water, so H2O, and carbon dioxide, which is CO2. Both of these are gases. So, what exactly is a chemical property? Well, a chemical property is any ability to produce a change in the composition of matter. In other words, the chemical makeup or what it's made up of changes. You could also say that you create a new substance, the ability to create a new substance. Ooh. Two examples we're going to talk about is flammability and reactivity. Before we can discuss those two, let's answer that key question that we put up a couple slides ago. Chemical properties can only be observed when the substance of matter changes into a different substance, or in other words, you created something new. So, of those two chemical properties, the first one we give is flammability. Think about it. Whenever you burn something, you're going to create something new, which is typically ash. If you burn wood, it leaves ashes behind. Same thing if you burn paper. But what exactly is flammability? Well, it's the ability for a material to burn in the presence of oxygen. So if oxygen is present, how likely is it to catch fire? One thing to take away from this is it has to do with oxygen. We don't care if they can burn in the presence of nitrogen or hydrogen. It's always going to be oxygen. Reactivity, on the other hand, is described as the property that describes how readily a substance combines chemically with other substances. So, in other words, how likely is it that one element is going to combine with another? Another thing you could look at is, for example, baking soda and vinegar. both of those are pretty reactive. When they combine, baking soda fizzes, and that's what you guys make volcanoes out of when you were little. Another example of reactivity is rust. Rust forms when oxygen in the air reacts with a metal. An example here is like iron. Water also helps it react faster. Now, if you don't know what rust is a brittle reddish brown color that appears on metals if they are left out in the rain or if they've been exposed to any kind of acid. This typically occurs on old vehicles. You can see it occur on bicycles. You can see it occur on old coins. The reason you see this occur is because the metal, typically iron, is pretty reactive to oxygen. So that oxygen combines with iron to form a new compound, which is rust. This is why you don't often see jewelry or coins made out of iron, because we don't like things that rust. Now you might ask me, well, Mrs. Grove, there's rust on cars and we still use cars to drive around. Luckily, if you take care of your car and its paint job, the car is actually painted over, and that coat of paint that they put on it and that sealer prevents rust from occurring as long as that doesn't break down and you take care of it. So now that we've kind of talked about what are chemical changes and when can you observe them, let's talk about, well, how do you know if something is undergoing a chemical change? Our key question here is what observations might indicate that a chemical change has occurred? Well, there are three types of evidence. The first is a change in color. Did it go from clear to blue? The second is the production of a gas. In other words, did you see bubbles? And the third is the formation of a precipitate. You do not know what a precipitate is, but we're going to define it here in the next slide or so. Now, there is one that I want you to add that is not here, but I go ahead and I'm going to tell you about it because if you do decide to take chemistry, it will pop back up. Another example of a chemical change is if you have a transfer of energy. And this might be in two forms. You might feel heat given off, or you might see a light that is produced. So let's define chemical change. We've talked about chemical properties. Well, a chemical change occurs when a substance reacts and forms one or more new substances. A good example of this is going to be a banana. It says the color change in a banana peel is caused by chemical changes that take place in the cells of the banana. So there are reactions happening that are creating new substances, which is why we see the color go from green to yellow to eventually brown. So if we're going to give a clue, we already said that a color change can represent a chemical change. Now, a change in color is a clue that a chemical change has produced at least one new substance. Again, if you use that previous example of the banana, we see a color change in the banana, and so we know hopefully that something new is being created. Other examples of a change in color might be if you have a shiny silver bracelet. If it's exposed to the air, sometimes it'll darken. Sometimes you might see it change your finger a different color. Another example is if you burn a match, it shrivels up and changes to be black or white depending on whatever ash it makes. And the last one is you can usually see a change in color for a chemical change is if a new copper roof was put on versus an old copper roof. Here is an example of what I mean by that copper roof. A new copper roof is about a reddish color. It's the color of pennies. But once it's left outside, it has a lot of different reactions with different compounds in the air. And so, for example, this building on the right-hand side, it had a copper roof, but it reacted and now it has a greenish color or a color change. Another example of a chemical change is if you see the production of a gas, or in other words, if you see bubbles. A good example of this is when you mix vinegar and baking soda, and this is a common thing to mix, for example, when you make volcanoes. What happens is those bubbles tell us that a gas has been formed. For example, here our gas is going to be carbon dioxide or CO2. Similar chemical changes happen when we use baking powder as an ingredient for cake recipes. What happens is those bubbles of the carbon dioxide expand and it helps cause cake to rise. The last clue is the formation of a precipitate. A precipitate, I said we would define it. It is defined as any solid, so it's in solid form, that forms and separates from a liquid mixture. In other words, I took two liquids, I mixed them together, and it made a solid. A good example of this is if you have an acid and you add it to milk, those proteins in the milk undergo a chemical change and causes them to clump together, and it forms a solid. And now, while this might sound gross, this is actually the basis of how we get cottage cheese. Here's where we're going to tie in what we learned in the last section to what we learned now. What is the difference between the chemical changes that we learned today and the physical changes that we learned in the last lesson? So, one of the things you can look at are different substances present after the change has taken place. If there are no new substances, then the change is physical, not chemical. Another way you could word this is when matter undergoes a chemical change, the composition will always change. If it is physical, the composition stays the same. So I'm going to go ahead and star that. That is going to be a big, huge thing on your test. Now, we went over 3 clues for chemical, but just because you observe one of these clues, you cannot be 100% certain that a chemical change has taken place. I'm going to go ahead and star that, raise that up. That's definitely going to be on your test. A good example is when an iron horseshoe is heated, the color changes from gray to red, but the iron is still iron. So even though you see a color change, it's not chemical, it's actually physical. So let's go through these assessment questions. Number 1, which of these properties is a chemical property of sulfur? A, yellow, B, flammable, C, brittle, or D, soft? So I want you to try and answer this on your own. If you had put B, flammable, you are correct. This is a chemical property. All of the other 3, yellow, brittle, and soft, are all physical properties because, again, you can observe and measure them and it does not change what it's made up of. Number 2, which of the following is not a common type of evidence for a chemical change? A change of state, B, a color change, C, a gas produced, or D, a precipitate formed. If you said A, you are correct. This is the only one that is not an example of a chemical change. What I mean by state is, does it change between a gas, liquid, or a solid? Whenever it changes between these, for example, if you have H2O in water form, and then it becomes H2O in gas form, it's still water, just in a different phase of matter. And the last one says you can be certain that a chemical change has occurred when A. There is a visible change. B. The change is irreversible. C. The temperature changes. Or D. A new substance is formed. If you had said D, you are correct. For example, the other ones are not true because here it says chemical change has occurred when there's a visible change. Sometimes you don't always notice a chemical change because it's occurring so slowly. A good example of this is rust. Rust is one of those changes that occurs over so long of time, it's hard to see. Second one is incorrect. The change is irreversible. I hate when they teach this in junior high. All chemical changes can actually be reversed. For example, if you make water, you can undo water and get your hydrogen and oxygen back. For the temperature changes, that does not necessarily mean chemical. I can heat up water and it's still going to be water. That is physical. And the last one we've already stated is correct because chemical, we create something new. So that is the end of today's lesson. Let me know if you have any questions and I'll be more than happy to help. And otherwise I hope you guys have a great day.